What if the safest path through the sky is not the shortest one, but the one pilots avoid for reasons you were never told? Every day, thousands of planes cross the sky, but if you look closely, you will notice they rarely fly straight across the map. Some routes bend around entire regions, even when going straight would save time, fuel, and distance for both airlines and passengers. This is not random, and it is not just about distance, because certain parts of the world are quietly avoided for very specific reasons. From dangerous weather patterns to invisible boundaries in the sky, there are places where planes simply do not go, no matter what. Some of these areas are well known, others are rarely talked about, but all of them have one thing in common: they are not safe to cross. And once you understand what exists in those regions, the way you look at the sky above you will never feel the same again. Because flying is not just about going from one place to another, it is about navigating a world filled with risks you cannot see. In fact, some of the most avoided places on Earth are not on the ground, but in the air above them. And the real reason planes avoid them is far more complex and sometimes more dangerous than most people ever imagine. The first reason is military airspace, where invisible borders in the sky can be more dangerous than anything on the ground below. Some regions are protected by governments, military bases, or sensitive facilities, and civilian aircraft are simply not allowed to pass through. To passengers, the sky looks empty, but to pilots, it is divided into controlled zones, warnings, restrictions, and hidden risks. A straight line may look faster on a map, but if it crosses restricted airspace, the plane must take a safer route around it. The second reason is conflict, because modern aircraft can become vulnerable when flying above regions with military tension or active danger. Airlines avoid these areas not because something always happens, but because one mistake in the wrong sky can become catastrophic. The third reason is weather, especially storms so powerful they can force pilots to change direction long before passengers notice anything. Thunderstorms, turbulence, volcanic ash, and extreme winds can turn a normal flight path into a dangerous, invisible obstacle course. That is why pilots do not simply fly through open sky. They constantly adjust around danger that most passengers will never see.
Altitude.
So when your flight path bends strangely, it may not be inefficient at all. It may be the safest decision being made above you. Another reason planes avoid certain regions is altitude, especially over massive mountain ranges where the ground rises dangerously close to cruising height.
Pull up.
Places like the Himalayas can be beautiful from above, but for pilots, they create serious
Center,
problems
Clipper
most
42,
passengers
Mayday.
never think about.
We are
If
experiencing
something
a
goes
rapid
wrong,
depressurization.
a plane needs space to
Executing
descend
emergency
safely,
descent.
and high terrain can leave very little room for error. Even oxygen systems matter, because at extreme altitude, an emergency descent may be impossible if mountains remain too high beneath the aircraft. That is why some routes bend around mountain ranges instead of crossing directly over them, even when the distance looks shorter. The same logic applies over remote oceans, where the problem is not height, but distance from help if something fails. Long ocean crossings require careful planning because aircraft must stay within reach of emergency airports along the route. If an engine issue, medical emergency, or system failure happens, the crew needs a place to land before the situation becomes worse. That is why airlines often choose routes that look strange on maps, but quietly keep the aircraft closer to survival options. In aviation, the shortest route is not always the smartest route because safety depends on what happens when things go wrong. Some flight paths look strange because maps lie to your eyes, especially when a round planet is flattened onto a screen. What appears curved on a map may actually be the shortest path across Earth's surface, known as a Great Circle Route. This is why flights between continents often seem to bend north, even when passengers think the plane should fly straight east or west. But near the polar regions, flying becomes more complex because navigation, weather, and emergency planning all become more difficult. Magnetic compasses become less reliable near the poles, forcing pilots and systems to depend on advanced navigation methods instead. Extreme cold can affect aircraft systems, while polar storms can develop quickly and leave fewer safe options for diversion. In remote polar areas, emergency airports are rare, and that makes every decision more serious when a flight crosses near them. That does not mean planes never fly near the poles, but it means those routes are planned with extreme caution. Sometimes what looks like avoidance is actually precision, where every curve exists to balance distance, safety, weather, and survival options. So the strange lines you see on flight maps are not mistakes. They are the hidden geometry of safety in the sky. Some places are avoided not because of weather or distance, but because the air above them is politically or legally restricted. In certain sacred military or government-controlled areas, the sky itself is treated like protected territory that civilian planes cannot freely cross. One example often discussed is Mecca, where religious, legal, and airspace rules make normal civilian overflights extremely restricted. Other regions are avoided because they contain secretive bases, sensitive defense systems, or facilities governments do not want aircraft flying near. Places like Area 51 became famous because the restricted airspace above them is guarded almost as carefully as the land below. Some countries also control their airspace very tightly, making international airlines avoid routes where permissions, safety, or communication may be uncertain. In these situations, the danger is not always visible, but the risk of misunderstanding, interception, or legal consequences can be serious. For airlines, avoiding a restricted zone is not weakness. It is a decision that protects passengers, crews, aircraft, and diplomatic safety. That is why flight routes sometimes bend around places passengers recognize, even when those detours look strange from a simple map view. The sky may look open, but above certain places, invisible rules can be stronger than mountains, storms, or distance itself. Weather is one of the biggest reasons planes avoid certain places, because the most dangerous threats are often invisible until it is too late.
Now.
A clear sky can still hide violent turbulence, powerful wind shear, and sudden air movement strong enough to injure passengers. Pilots use radar and forecasts to avoid storm cells, because flying through the wrong cloud can become extremely dangerous. Thunderstorms can push air upward and downward so violently that even large aircraft must go around them instead of through them. Volcanic ash is even more dangerous because tiny particles can damage engines, scratch windows, and confuse critical aircraft sensors. Unlike normal clouds, volcanic ash may look harmless from far away, but inside it, engines can lose power without warning. Extreme heat over deserts can also reduce aircraft performance, making takeoff, landing, and emergency planning more complicated. Strong winds over mountains create invisible waves of air that can shake aircraft violently, even when the weather appears calm. That is why pilots may avoid a region that looks harmless from the window, because instruments reveal dangers passengers cannot see. In aviation, the sky is never truly empty. It is filled with moving forces that decide where planes can safely go. Some regions are avoided because the problem is not the land below, but the lack of support in the air above it. Modern flying depends on radar, radio communication, navigation systems, and air traffic control working together almost perfectly. When those systems are weak or unreliable, pilots lose some of the invisible safety net that normally protects every flight. Over remote oceans, deserts, jungles, or politically unstable regions, communication can become limited, delayed, or much harder to maintain. Air traffic controllers need to know where aircraft are, how high they fly, and whether another plane is nearby. Without strong monitoring, safe separation becomes more difficult, especially when weather changes, emergencies happen, or routes become crowded. That is why airlines often prefer routes with reliable communication, strong navigation support, and clear access to controlled airspace. A route may look longer, but if it keeps pilots connected to help, it is usually the safer choice. In aviation, silence is dangerous because a plane that cannot communicate becomes harder to protect when something goes wrong. So pilots avoid not only visible hazards, but also places where the sky becomes too quiet to trust completely. One reason planes do not always fly straight across oceans is that safety rules require backup plans long before anything goes wrong. Long flights over water must consider how far the aircraft can safely fly if one engine or system fails. This is where ETOPS becomes important, a safety standard that controls how far certain aircraft can fly from emergency landing airports. That is why ocean routes often follow invisible corridors shaped by fuel, weather, regulations, and emergency airport access. Across the ocean, the smartest path is not the straightest line, but the route that keeps survival within reach. Many people think strange flight paths mean airlines are hiding something, but most detours are actually based on safety and mathematics. A plane does not avoid a region just because it looks mysterious on a map or because rumors surround that place. Most of the time, the real reasons are weather, airspace rules, terrain, fuel planning, communication, and emergency landing access. What looks like a strange curve to passengers can be a carefully calculated decision made long before the aircraft even takes off. Airlines are not simply choosing the shortest line, they are choosing the safest possible route through a changing global system. Sometimes the safest path costs more fuel, more time, and more planning, but it reduces the risk passengers never see. This is why two flights between similar cities may follow different paths, depending on weather, politics, traffic, and aircraft type. Even a small change in wind, temperature, or airspace restrictions can shift a route hundreds of miles from what you expected. So the next time your flight bends oddly across the screen, it may be following logic deeper than the map can show. The sky is not a blank space. It is a controlled system where every invisible rule can change the path above you. So the next time you see your plane turning away from a straight line, remember, it may be avoiding something invisible. It could be weather, military airspace, mountains, weak communication, emergency planning, or a rule written long before your flight began. To passengers, the sky feels open and endless. But to pilots, it is filled with boundaries, systems, and decisions. Every curve on the map may represent a storm avoided, a danger reduced, or a safer place to land if needed. The plane is not wandering. It is following a path shaped by science, law, geography, and survival. And the safest journey is rarely the one that looks shortest. It is the one that gives pilots options when conditions change. That is the hidden truth behind modern aviation. The route you see is only the surface of a much deeper system. Behind every flight path is a quiet calculation made to keep hundreds of lives safe above a changing planet. So maybe the real mystery is not why planes avoid certain places, but how many dangers they avoid without us noticing. Because in the sky, safety is not always seen, but it is always being calculated before you ever arrive.